So you've decided that you do need a sunlight readable or very high bright display for your application. But how do you go about comparing all the different models that are out there on the web to make sure that you end up with the right monitor for your project? I'm Keith with Panel-Brite, and that's what this video is all about. Different manufacturers list things differently in regards to specifications of their product. So what we want to do is to help you to look at specification sheets line by line and to get a true comparison of the product so that you can make an informed decision on which one is actually best for you. We also want to give you some ideas to look for in regards to certain specifications that you may not have thought about before. So the first thing we want to take a look at is very obvious, but it's just the dimensions listed on the specification sheet. Now I only mention this because in being in business for 13 years, I've actually seen this mistake committed a couple times by folks that are working on projects. There's usually two dimensions listed on the specification sheet. The first dimension typically listed is the actual display dimension. That's what you're actually seeing on the display. The second dimension that's usually mentioned is the outside specifications of the monitor itself. Now, if you're mounting the product inside, say, a kiosk with a cutout that you're only seeing the actual display, obviously it's important to know that dimension. However, if you're mounting from the top side or it's going inside of a case that has limited space, then the total outside dimensions of the product may be the most important, or both specifications may be very important to you. But just make sure that when you're looking at the data sheet, you're looking at either the display dimensions or the mechanical outside dimensions. And if it's not listed in the actual specifications part of the sheet, you might have to go to the mechanical drawing, which is usually at the bottom of the specification sheet, and actually look at it to acquire those different dimensions. So the next thing we need to take a look at are the signal inputs on the monitor. Obviously, you know for your application what you're going to be feeding the monitor in regards to a signal, whether it's coming from a motherboard, a full mini PC, or a digital media player. So you could have HDMI, DVI, VGA, DisplayPort. There are many different types of connectors. And we just want to make sure that whatever monitor that you're looking at, you look at the specification sheet. Usually the monitor is going to have several inputs, but make sure that it matches up with the one that you're looking for. Or if it's in the case of only having a DVI on the monitor, but HDMI, there is a converter plug between the two of those, but that you have clearance and room on the back of the monitor or in your application to consider the space required for the converter plug to be used. Now the next thing we need to look at specifically if the monitor is going to be used outside is the brightness level that we mentioned before, the nit rating of the monitor. Now one thing I just want to mention here about nits is that it's not a linear scale. What I mean by that is that a monitor that's 1000 nits is not twice as bright as a monitor that's 500 nits. And you can actually reach a point of diminishing return. So if you're trying to push a monitor at 5000 nits brightness, say, you're actually going to be generating so much heat in the unit that's an enemy of the components, the electronic components inside, that's actually detrimental to the product, and you're not really going to see any more benefit in the sunlight readability of it versus, say, a 1500 nit monitor. So again, just to summarize what we talked about in our previous video, if you're in an indoor type of ambient light conditions, say like in a mall with an atrium overhead, something at least up to a 500 nit rating is probably going to be required. Outdoors, if your product is under a hood or some type of cover where you're not getting direct sunlight on the screen, at least 800 nits of brightness would be required, and direct sunlight shining right on the product, a minimum of 1000 nits. 1200 would even be better, or 1500 nits. I think the sweet spot really for a sunlight readable display is in between that 1200 to 1800 nit range for the product. Now, in addition to brightness, really the other component of that that's as important, maybe even more important, is contrast. Now, contrast is important because it's actually what your eye sees when you're looking at a monitor. Contrast is simply the difference between the brightest whites and the darkest blacks. So you can see in the illustration before you that the circle is white, but if we split it out and put it on different backgrounds, one being a lighter background and one being a darker background, the circle actually looks sharper and brighter against the darker background. That's contrast. Likewise, if you've ever gone into a dark restaurant and you're older like me and you're having a hard time seeing the menu because it may be a lighter font that's written against a lighter background, that's because there's not enough contrast between the print and the page that it's printed on. It's the same type of thing. So a monitor needs to have a really good contrast in addition to brightness for your users to be able to see your content. Typically, we recommend a contrast ratio of at least 500 to 1 to have a good contrast. And the higher the contrast, the better that your eye is going to be able to view the content on the screen. So that's a very, very important specification to compare when you're looking at different spec sheets. The next thing we want to look at is operating temperature. Now that's how much temperature the display can handle, especially internal temperature, before it can have issues. Now typically the display can go beyond what the listed operating temperature is because the manufacturers want to have a lot of leeway there in the specifications. The monitor that I'm looking at here has an operating temperature of 0 to 40°C. The monitor on this specification page goes all the way from -30 to 85°C. So this is what we call a wide temperature range monitor. Now that can be really important if you're outside in a kiosk type of application with the sun shining directly on the screen, or also in a cold environment up in the northeast or northwest where you're going to be getting very cold monitor as well. What we want to make sure is that our monitor can handle the environment that it's going to be exposed to, especially in direct sunlight, so that it doesn't go isotropic. Now that's a fancy word that means the monitor can black out. Actually what's happening is the liquid crystal inside of the monitor is getting so hot that the crystal form is changing and it's not allowing the light to pass through. But to the naked eye it just looks like part of the monitor has a black ink behind the screen on it, or the entire monitor can go black. Usually that's not permanently damaging to the unit. Once it cools down, the liquid crystal will again take shape and be able to work correctly, but it's not helping your application if your customers can't see what's on the screen. So pay very close attention to the operating recommendations, the operation temperature of the monitor, and if you're going to be outside in direct sunlight, you really need to be looking at high temperature displays that are in that -30 to 80+C range as far as their operating temperature. Now the last two things I want to take a look at aren't necessarily always specifications written on a sheet, but you can usually get them from the manufacturer if you ask. Power requirements may be, but these are things that come into play in regards to cost. Obviously cost is a very important component of what you're looking at in your overall return on your investment for your product, and it's hard to compare the cost of different products in the sense of not just their upfront costs, which is easy, you can just look at what you're going to be charged, but what's the overall cost going to be for maintaining that product over the life cycle of your application. So one of the things that we can take a look at is MTBF, mean time between failures. That's a rating in the industry that says how often a unit breaks. And it's based on a calculation that we're not going to get into, but the bottom line is the higher the hours rated for the product, the more reliable that product has been in testing, the lower the number for that specification, the more often that it's going to have failures. The product that I'm looking at on this specification sheet is rated at 50,000 hours MTBF. The one on this sheet doesn't actually have a rating, but I called up the manufacturer and it's actually rated at 100,000 hours MTBF. So obviously this is a very reliable product, and that can mean a lot of difference. Even if it was more expensive up front, in the long run that type of product might be less expensive for you to use in your application. And the final thing we're going to take a look at is the power requirements of the product. Now this could be for two reasons. If you're going to be using the product in say a solar or battery environment where you're in a kiosk that has a solar panel on it and your screen is actually receiving power from that, or in some type of application where it's receiving power from a battery, the lower the power requirement itself could be very important to that specific application. But another point that I want you to look at in regards to power requirement is the efficiency of the display. And again, this goes back to how reliable the display might be over the life cycle of your product. There's a lot of companies that can high-bright a display simply by going out and buying various components. A high-bright LED light strip, an LED driver to go along with that, and they cobble all of those things together into the display. And it may be very inexpensive to be able to sell that type of display to someone, but is it really going to be reliable over the long haul? One of the things that you can look for that will usually indicate a higher quality display or monitor is the power requirement versus the brightness of the unit. Because to get a brightness that's quite high but with a power requirement also that's quite low on the unit, it usually means that the components were all designed to work together in a very efficient manner in order to produce that type of ratio between those two. We can see on this specification sheet that this manufacturer has a nit rating of 500, so it's on the bottom end of a high-bright panel, and yet the power requirement is 41 watts for this unit. This particular monitor is a 1600 nit unit, so it's quite bright, and yet it only has a 43 watt power requirement. So it's a much brighter product, but it only is pulling 2 more watts of power, which would tell me that this is a much more efficiently built product. It's probably of a much higher quality. So even though it may cost more initially than this product, over the long haul, it actually may be the less expensive product in regards for you using it in your application. That's something that you need to weigh and decide on your own. So hopefully we've given you some good information here for you to look at in regards to evaluating products, with looking at different specification sheets, and also a couple things to look at that maybe you haven't thought about. So I'm Keith with Panel-Brite. We appreciate you watching, and we wish you the very best with your high-bright monitor application.